Want to find your own diamonds? There's something about finding diamonds that just gets people excited. You know, it doesn't take a whole lot of diamond in a rock to be really valuable. Now, kimberlite, that's what we're going to talk about today. It's the important ore of diamonds. There's also another rock called lamproite. We'll talk a little bit about that too. But the main ore of diamonds is a rock called kimberlite. Kimberlite is a kind of volcanic rock, but a very rare and unusual one. I do get people saying, oh, there's a volcano near me, so because there's a volcano, there must be diamonds. Well, not really. Kimberlite is a 1 in a million kind of a volcanic rock. But you know, there is a number of them that are known, and geologists think that there are actually a lot of them to be discovered because, well, most of them are covered with soil. Unlike your standard volcano that you think of that sticks up out of the ground and lava or volcanic ash or whatever comes out of the top, kimberlites are a lot different. They're often depressions in the ground. There is no mountain that indicates the volcano. We're going to take a look at that because it's kind of unusual. But because it's unusual and it's flat like that and there's nothing sticking up, quite often they're just covered over with the local area soil. And so geologists think that there's a lot of them out there to be discovered. Want to be involved in maybe discovering a super rich deposit of kimberlite, a kimberlite pipe? Well, watch this video because we're going to get into the details. We're going to talk about what makes a kimberlite a kimberlite. We're going to look at all different kinds of ones. We're going to look at stuff that kind of looks like kimberlite but isn't. So you'll be able to distinguish it and learn the indicator minerals. We're going to talk about that. The indicator minerals that will tell you that there may be a kimberlite pipe nearby. Now, this is a kind of a little bit technical sort of a topic, so bear with me because I'm going to go through a lot of geologic terms and things like that and mineral names and stuff, but bear with me and I will unpack all of that for you and explain all of it in ways that anybody can understand. It's not really that hard a concept, but if you use all these technical terms, people just go, oh, what does that mean? So we'll use the terms and be correct, but we'll unpack them and explain the details of it as we go along in the video. Once you have the idea and the description for kimberlite rocks well in hand and fixed in your mind, then we'll go into what it takes to go out and look for kimberlite rocks. But first, let's take a closer look at kimberlite and diamonds.
Here we have a beautiful, nice gem quality diamond sitting in a chunk of dark colored kimberlite. And I want you, to notice and looking closely at this, look at the little tiny crystals around the outside of the diamond. There's some kind of yellowish colored, yellow-brown kind of crystals. And remember that kimberlite has other crystals that have grown into it in addition to the diamond. And it's these other crystals that we'll eventually be talking about and using to trace and find kimberlite bodies. Here's a real nice octahedral crystal of diamond in a very dark matrix of kimberlite. Now, this crystal is maybe not as clear. It looks like it may have some flaws in the upper part of it. But even so, most of this is diamond that's gem grade. But look at the kimberlite. It looks a little bit different. We don't see the other crystals in there with it, and it's a very dark matrix that surrounds it. Here's a beautiful octahedral crystal in a chunk of kimberlite, but you can see this kimberlite is a little bit more brown. There's some lighter tones there. I think this piece has just been oxidized and weathered a little bit. Not much, but a little. Now, specimens like this that I've been showing you of the diamonds in kimberlite are really valuable because they're rare, and mining methods that are used mostly to extract diamonds from kimberlite rock don't give chance for specimens to be collected. They go into, truckloads of material that get processed, and nobody's hand sorting the material before it goes into the mill. They hand sort the diamonds after they come out, but they don't hand sort the rock itself. Here's an interesting specimen. You can see that this kimberlite rock, this piece, is river rounded. This is obviously something that broke off and tumbled through a river, and you could still see the diamond sticking out. That this diamond is a little bit on the brown or champagne side of coloration. But I want to point to the upper left-hand side. There's some dark red crystals there. Those are garnets, and they're a special type of chrome-rich pyrope garnet. It's one of the indicator minerals for kimberlite. So we've been looking at some dark, unweathered, or at least maybe minimally weathered examples of kimberlite and diamonds. But here is a diamond sticking out of a fairly well-weathered piece of kimberlite. And you can see it looks much different than what we've been looking at. And you can see the little bits and pieces of the breccia, the other light-colored rocks that are swallowed up in the kimberlite. And this is why I say that different specimens of kimberlite can look a lot different. Here's another lighter weathered green-gray piece of kimberlite. And again, it looks a lot different from some of the other things that we've looked at in the last few minutes. But this is an example of what kimberlite starts to look like when it starts to weather. But you can see the diamond in it. It's kimberlite.
So let's talk more about what kimberlite is. It's a dark-colored, heavy, brecciated, which means fragmented, igneous rock that contains diamonds in the rock matrix of the rock. It has a porphyritic texture, which means that there is inside the rock little crystals of minerals that grew when it was deep in the ground. And some of the crystals that grew are diamond, but there's other minerals too, and those are actually much more common, and those will end up being our kimberlite indicator minerals. The crystals are in a fine-grained matrix of the rock. So, it's not a coarsely crystalline rock like a granite or a gabbro or something like that. It's a volcanic rock, but it may have bits and pieces of other rocks in it. That's what a breccia is. And it has these little phenocrysts, the little crystals of other stuff that grew. And like I say, diamond is the one we're looking for, but it's not the most common. A lot of other minerals will grow and indicate that they formed in a kimberlite type of environment. The most abundant mineral in kimberlite is a mineral called olivine, or one form of olivine or another, because there's different end members. There's the iron-rich end member and the magnesium-rich end member. We'll talk about those. But other kinds of minerals that are abundant in kimberlites include things like certain types of mica, chromium-rich pyrope garnets, chrome-bearing diopside, magnesium-rich ilmenite, serpentine, calcite, and magnetite. Kimberlite almost always starts out dark in color, but it weathers like a lot of kinds of rocks. It weathers kind of easily. And so then once it weathers, it gets lighter in color. And so what you may see on the surface may not be dark. It may be rather light. And we're going to talk about that as we go through and look at pictures of kimberlites. Kimberlite, along with the important other host of diamonds, which is lamproite, they basically form deep in the earth and come up great distances to get to the surface, because it takes that great depth down in the earth to have sufficient pressure in order to form diamonds. Diamonds have to form at a great pressure and a reasonably high heat too. It's not near surface heats. It's pretty hot down there. You're almost getting to the level where you're starting to encounter molten rock down there. So it's from deep within the earth. Both of the types of rocks are. Kimberlite and lamproite are really quite similar. We're going to talk a little bit about that. But what they do is by basically blowing up, exploding upward through the earth, they bring the diamonds that form deep in the earth up to near surface where humans can reach them. And when they explode like that, they eventually solidify into these pipe-like structures. Now, I've used a lot of geology terms, and I've said that I will unpack all this stuff if you're patient with me. But first, let's take a look at how kimberlites form, where they form, and where they're most likely to be found.
Diamonds are formed super deep in the Earth's crust, and the lithosphere, the part of the mantle that's solid. Now, you can see on this diagram, the asthenosphere is the part where it starts to be molten. The asthenosphere is kind of like mush. It's not really solid and not really liquid. It's kind of mush. But above that, the parts marked gray on this are the solid part, either the Earth's crust or the uppermost part of the mantle that's still solid. And it's the very deepest parts of these where diamonds form. This diagram kind of shows how that works. In general, the solid part, the surface part of the Earth's crust and the top part of the mantle that's still solid are generally not more than, well, from 20 or 30 up to 50 or 60 kilometers deep. So we're not talking huge depth, but at that depth, graphite is the more stable form of carbon, and you won't form any diamonds. You have to get really deep, down maybe below 140 kilometers, below 100 miles or so deep, that you would get towards the stability area that diamond is the stable form of carbon. It just takes that much amount of huge pressure to make the graphite form into diamond, for diamond to be the more stable form of carbon. But the problem with this is it has to be brought up quickly. And the only parts of the continental crust that are that deep are some old parts that we're going to talk about in a minute called cratons. And these are basically the core of the continents that is the part that hasn't been affected by volcanic action and other more recent geologic action. The old part that's the core of the continent is what's called a craton by geologists. And it's underneath these that the solidified rock, the mantle, is the thickest, and that's where you have to be to form diamonds. But the other thing is that the diamonds have to come quickly to the surface, because if you have a diamond formed down deep and then slowly over eons of time, the diamond manages to make its way up and up and up and eventually is erupted out onto the surface by a normal type of volcano, long before it gets to the surface, the diamond will be destroyed and turned back into graphite or something else, and so you won't have diamond. And that's why regular volcanoes, even ones that draw from a very deep reservoir of magma, don't have diamonds. It takes this special kimberlite that's basically an explosion that roots from way, way, way down deep, where the mantle is deep enough and where the solid rock is deep enough that diamonds can form, and then it gets brought to the surface really quick. It's this very strange kind of volcano that goes down really, really, really deep and basically explodes upward. And what causes that is there's actually trapped moisture down there, and when the pressure of the water gets too great, it basically causes a rupture that goes all the way to the surface. And that's what brings the diamond crystals from way down deep and brings them up to the surface, or near to the surface, where they can be worked and recovered by men. Now, it also brings up pieces of rock, xenoliths, and other minerals that form down deep besides diamonds, and it brings them to the surface too. But this is not your standard volcano or anything even remotely like what most people see when they think of a volcano. But this type of pipe-shaped explosion is why most diamond mines, you can see from this picture, are basically circular, with going down smaller and smaller as you go down the pipe. And you can see these are a couple of mines. And the other thing is that these kimberlites frequently form in group, but they do have this obvious conical pipe shape that is visible both in the geology and in the mines as well. Here's a map showing the craton areas. They're kind of shown in gray here. And we're going to dig into this more deeply because this shows both where there are known kimberlites as well as other types of diamond-bearing rock. And so we'll come back to this map, but just to give you a feel, there's Australia, there's, a lot in southern part of Africa, India, and of course North America and into Greenland and certain parts of Russia and that. So anyway, we will get to this in more detail in a little bit further on in this video.
Okay, so let's dig into some of those geologic terms, and I mentioned that I would unpack them. Let's dig into the terms and figure them out and understand better what they really mean. Now, I mentioned that kimberlite is a volcanic breccia, and basically we talked about it coming up from deep in the earth. Well, as it explodes upward, it breaks through all the rocks that are above it, and the fragmented bits and pieces of rock that are above it are incorporated into the mass of the lava that is the kimberlite. And so you'll see kimberlite with bits and pieces of other kinds of rock inside it. Sometimes these are called xenoliths because they come from deep down and are very unusual kinds of rocks. Sometimes they're more near the surface types of rock, and they're just other rocks that are incorporated into the kimberlite. Kimberlite also tends to weather really easily. The effect of air and water on the minerals that make up kimberlite tend to change it and alter it and turn it into other minerals and other things and change the color a lot. So, what you see from the pictures that I'm going to show you of fresh kimberlite and what oxidized weathered kimberlite looks like, they're two very different looking things, even though they're the same kind of rock, or at least originally they were. Once they're weathered, there's a lot of changes that happen. And I talked about having a porphyritic structure, meaning that there's crystals of other minerals that grew in the ground mass, that you had this fine mass of lava or molten, semi-molten rock, and the crystals grew within that. Some of the crystals that grew were diamonds, but other crystals also took place, and like I say, these are going to end up being our kimberlite indicator minerals. But we're going to understand that there's these other crystals that grew in the matrix, in the mass of the kimberlite when it was deep down within the earth. There are actually lots of different kinds of volcanic rocks that have phenocrysts in them, and sometimes they're used as gemstones. I've done some videos on how gems form out of volcanic rocks, and actually gems, rubies and sapphires, and certain types of feldspar and some other minerals are very common spinel. They crystallize out of molten lava, depending on the nature, the chemical nature of the lava and the temperatures that it's at and how fast it cools and that sort of thing. But you can get these crystals form in there. Well, kimberlite is a very different kind, but it forms a number of different unusual minerals, and we're going to see that, of course, the real valuable one is diamond. So to get familiar and dig into kimberlites, let's take a look at a whole bunch of pictures of natural kimberlite, both weathered and unweathered.
So here we have a piece of kimberlite from the state of Colorado. And for those of you who don't know, there actually was a working diamond mine in Colorado for a number of years. This is a piece of their diamond ore. And you can see, like most fresh kimberlites, unweathered, it's dark in color and it has bits and pieces of other rock in it, usually very angular bits and pieces. But this is a start of looking at some different kimberlites, and we're going to look at a bunch of different ones. Here's another piece of kimberlite from the same deposit in Colorado, only this piece shows a whole lot of pieces of dark red pyrope garnet that are rich in chromium. And it's when the kimberlite breaks down and falls apart and weathers, the garnet will be released and it'll go into streams, and then these kinds of garnets can be traced back to the source kimberlite that was the host. But you can see the dark colored matrix that the crystals originally grew in, and this is an indication of what kimberlite looks like. Here's some fresh, dark-colored kimberlite from Antarctica. And you can see various crystals growing in it. There's a pretty obvious green one there in the middle, and that's a chrome diopside. Diopside is a mineral, and then it's chrome rich. It's got chromium in it, in the crystal, and that's what gives it that emerald green color. And emeralds are also colored by chromium. So anyway, you can see little crystals growing in this, and these are the kinds of things that give rise to the indicator minerals. But you can also see the dark ground mass that is the color of the unweathered kimberlite. Here's yet another example of kimberlite, again dark and unweathered, but this one with lots of pieces of different kinds of rock that have been, all of which are lighter in color, that have been incorporated into the mass. And you can see that this is a breccia. Some of the pieces are a little bit rounded, some of them are more angular. Some of the pieces actually get ground up as they are blown up through the kimberlite pipe. The edges are milled and rounded off. But let's take a look now at some of the more weathered pieces of kimberlite. Now, this is a piece of kimberlite that's been sawn and kind of polished so you can see the material of it real easily. You can see the different colored angular rocks that have been caught up in it. But the dark colored ground mass that we've been looking at in the samples before this, the ground mass is now more of a lighter gray color because it's begun to weather, and the minerals that make up that volcanic mass, the matrix, the ground mass, have begun to change by the effects of air and water. This is a piece of kimberlite from the state of Kansas in the United States, and it also has begun to weather, and the basic ground mass, the background, the thing that everything is suspended in has turned more of a gray, although in the upper right-hand corner, you can kind of see an area that didn't get weathered as much, and so the background mass is still darker. So as it begins to weather, it can change color very definitely. Sometimes, depending on the actual conditions of weathering, the mass of the background of the kimberlite may weather to more of a greenish color, as in this example. Now, this piece of kimberlite is from a very famous diamond-producing mine in Canada, known as the Davik. Here's another image of some greenish kimberlite, a weathered kimberlite. And, greenish is not an unusual color. A lot of kimberlites that are weathered do have this color, and it has to do with the iron that's in the volcanic mass, the dark-colored mass that is in the unweathered kimberlite, that as the iron weathers, it can change color and become this green. And here's another green round mass piece of kimberlite. And you can see this one has a number of different kinds of rocks that were caught up into the matrix as this thing exploded upward from its great depths. And I hope you'll get the feeling now that green is actually a fairly common color for kimberlites, at least for weathered types of kimberlites. As the iron in the kimberlite volcanic mass weathers even further, it can turn yellow. And in fact, yellow kimberlite was famous in the earliest years of diamond mining in South Africa because they discovered what they called yellow ground, and it was just very highly weathered and altered kimberlite near the surface. And so this yellow color is certainly not unusual at all, but indicates that the kimberlite has been very highly weathered. And here's yet another piece with a completely different color. Here, instead of turning yellow, the iron in the matrix mix has turned a kind of a rust red brown. And this is a piece of kimberlite from Russia, and it shows the typical bits and pieces of rock that it caught up. And if you look closely, you can see there are some crystals that grew in here. And like I say, it's from an active diamond mine in Russia. This is just the material on the surface of the kimberlite pipe that has weathered and been exposed to air and rain, and over a long period of time, the ground mass that was originally dark in color has weathered and weathered and weathered and weathered, and now is this rust red colored material. So, the color of the material and the background material and even the color of the rocks within it are not a good diagnostic to help you determine if it really is a kimberlite. It's more the things like the crystals growing in it that can tell you what really is kimberlite and what is just a common volcanic breccia rock.
Now, I have noted when we're talking that kimberlite is a kind of volcanic breccia. It's a lava that's incorporated other kinds of rock that are caught up into the lava and mixed in there. Unfortunately, general volcanic breccias are really not that unusual at all. And kimberlite, though, is super rare, super duper rare. Sometimes people get out and, they're hunting around and they may find chunks of stuff that are clearly lava and yet have chunks of other rock in it. And it may, at least superficially, look a lot like a kimberlite, but they're not really kimberlite. So we're going to talk about similar rocks that look like kimberlite, but are not. So let's compare these different kinds of rocks and between the volcanic breccia that's common and the kimberlite that's really rare. And let's compare the two and talk about the differences. One of the differences I've mentioned too is that kimberlite is a rock that has little crystals that have grown in it, phenocrysts, I could call them, crystals that have grown in the mass. And most volcanic breccias do not have any significant crystals that have grown in the mass. That's maybe perhaps the easiest way to differentiate between the two. But let's look at a whole bunch of pictures and really dig in and compare the two.
Here's a piece of just common volcanic breccia. It's not of any particular value. It certainly doesn't have diamonds or other valuable minerals in it. And yet it looks a lot like the kimberlites that we've just been looking at. And here's a piece of kimberlite from Russia that we just were looking at a minute or two ago. And look how they look the same. You can see why people mix up the two, and you can't look at this and say, well, okay, this background color is more brown and the other one was more reddish. That's not a good determination. The background color on this could be more reddish and the other one could be more brownish. The color just isn't a useful diagnostic. And you look at the pieces, the angular pieces in here, it's clearly a breccia. So it's very similar in appearance, and you can see why it fools people. Here's some pictures of volcanic breccia from Texas, and Texas does have some volcanic rock in places, and the guy who found this was utterly convinced that he'd found a kimberlite in Texas. But no, this is just common volcanic breccia that, like I say, is of no particular value. Now you say, well, this is kind of different from some of the kimberlite samples we looked at so far. Well, take a look at this. This is a piece of actual kimberlite from Finland, and you can see it looks very similar with the same large style chunks of rock in it that are mixed up in there. It looks very similar to the Texas material. Here's another piece of common volcanic breccia, and it looks similar to some of the weathered specimens of kimberlite that we've looked at. And you can see the chunks of angular, dark-colored, and light-colored rock that are in this volcanic breccia. But this is not kimberlite, and you can't look at the background color and say, well, it's a little bit different than some of the kimberlites we looked at because, well, the background mass color is not a good determination to decide whether it's kimberlite or not. Here's another piece of volcanic breccia, a common volcanic breccia with light-colored pieces in it and a dark ground mass. It looks, again, very similar to the kimberlite things that we've seen so far. And here is a piece of actual genuine kimberlite, which looks very similar to the piece we just looked at. And yet this is the genuine article. Now, the difference is that this will have phenocrysts in it, little crystals that grew in the ground mass. Now, it's possible for volcanic breccias also to have phenocrysts in them, although it's uncommon. You can find it in some rare circumstances. So the next step would be to actually have the rock analyzed, because actual kimberlite will have elevated levels of chromium and nickel, which indicate that it came from deep within the Earth's crust, deep down, because deep down those elements are a little more common than they are in the upper part of the crust. And so that's another strong indicator if you have real kimberlite or just something that is a good look-alike.
Now, I've said that kimberlites are very commonly, because they don't have it's not a volcano that sticks up like a mountain. It's something that doesn't even show at all on the surface. There's no hills or mountains that are uplifted by the volcanic action of the kimberlite, because it comes from down so deep, and often they're so old that any indication of something sticking up is weathered and washed away and impossible to see. And so the kimberlites themselves are covered over with soil, and that makes them really difficult to see. And we're seeing today in Canada that they're mining diamonds in a number of places, and they've made a number of kimberlite discoveries in locations in Canada. And a large part of that is, like, we've known based on the diamonds that have been found in the glacial materials in the Midwest that there's diamond sources somewhere up there in Canada. That's been known for decades. I think they understood that, at the turn of the century, in the 1900s, the early 1900s. They understood that there must be some source of diamonds in Canada, but it took a long time to find them, because a lot of them are buried under glacial till or soils or other materials, and they can be really hard to find. And so what's happened is we've developed this technique of using these minerals to trace the kimberlite from the downstream area where you're getting some of these minerals back up to the source, the kimberlite pipe itself, where these minerals are coming from. Now, like I say, these phenocrysts, these minerals are unusual. The minerals themselves may be less unusual, but they have chemical indicators in them. Like, some of them are high in chromium or high in nickel or other things that indicate that they came from deep within the earth, and are not, near surface type of minerals. And so these minerals can be identified and traced back to find the source. And this is a thing that's been used in Canada a number of times, very successfully, finding various diamond pipes. And now Canada is a major source of diamonds when, there were no obvious kimberlite pipes, but using some of these kimberlite indicator minerals and other indications, the geologists were able to find these kimberlite pipes. And there's potential to find them in a lot of different places. Canada is not the only one, but it's one of the ones that have been the most successful and the most obvious, where, we knew that there had to be something up there, but it took a long time to find them. So the kimberlite indicator minerals, they formed under high pressure and deep down within the earth. And like I say, they include things like chromium-rich diopside, chromium-rich spinels, magnesium-rich ilmenite, and pyrope garnets that are rich in chromium. And they're generally found, these kinds of rocks, these kinds of minerals are generally not found in normal igneous rocks that are from the surface, normal volcanic rocks or igneous intrusive rocks like granite, or even in metamorphic rocks either. You just don't find these kinds of things. That's why they're kind of unique. And so they make good indicator minerals. And so what people do is they sample sediments on a large scale. They might take one sample every mile or every kilometer, something like that, and do an analysis. And they'll analyze for these unusual kimberlite indicator minerals. If the kimberlite indicator minerals are found in the samples, the next step is to tighten your grid. And if you keep tightening the grid, taking more samples in a smaller area, and you keep getting these kimberlite indicator minerals, eventually you get to a point where you may want to drill or do some trenching to see if you can't expose some of the kimberlite on the surface. This sampling and looking for these indicator minerals can take a lot of work and a lot of time, but there's a lot of situations where governments, and the Canadian government has done this, has gone out and taken a number of samples in different places and prepared information in databases that people can use to assist them in searching for these kimberlites. Let's take a look at these special indicator minerals and how they're used to find kimberlite pipes.
So the mineral on the left is a red high chromium version of pyrope garnet. Now, pyrope garnet is found in various places, but this is a chrome-rich version. And then on the right, the green is a chrome-rich diopside. So again, it's a common mineral diopside, but it's rich in chromium, which gives it that emerald green color. Next, we have on the left is a magnesium-rich version of olivine. The gemstone is known as peridot, and this is a magnesium-rich end member that doesn't have the iron that colors it green, and that's why you get this type of appearance. And on the right, we have a chromium-rich spinel, and it's got so much chrome in it that it's super dark. So this is another unusual form of spinel, but it's chrome-rich, which indicates the depth of its formation. And finally, for our indicator minerals, we have on the left the orange-colored garnet. It's a pyrope and almandine mix. And then on the right, the dark mineral is ilmenite, which is an iron titanium, but this is a magnesium-rich version of that mineral. Anyway, these 6 indicator minerals have been used in a lot of different kinds of searches for kimberlite bodies. Now, you would think that the best mineral to use for looking for kimberlites would be these, the actual diamonds themselves. But the truth is that there are not huge amounts of diamonds. Diamonds, even in a good kimberlite, are fairly sparse, and so not that many of them make it into streams and rivers and reasonable areas that can be tested for their gravels. And because the other kimberlite indicator minerals are so much more plentiful in the kimberlite, they make a much better source that you can trace to the original source. So let's look at how they trace these indicator minerals back to the source kimberlite. Here's a little diagram that explains how kimberlites would appear in areas where they were buried by soil or till or glacial material. And the upper diagram, you see the buried kimberlite pipe, you see the round brown circle, and then it spreads out, and because the material is moving from left to right. So the soils are moving from left to right. And then you can see that as the material goes downhill, it spreads out. At the far right-hand side, the spread of the kimberlite materials, the indicator minerals and geochemical anomalies and stuff is much wider at the far right than it is at the actual spot where the kimberlite pipe is. And you can see in the first part of it there, before the stream crosses, it's actually below the surface, but then where the stream crosses, it comes to the surface, and downstream from the kimberlite pipe, there are concentrations of heavy minerals. And some of those minerals could be panned out, collected with a pan, just by panning soil samples. Then the lower diagram shows a cross-section, a vertical line through the kimberlite pipe, showing that the green, the soil covers over everything and buries it. But as material moves from left to right, it works its way to the surface. And where the stream crosses, as in the upper diagram, there's a heavy concentration of heavy minerals, and you could get geochemical anomalies testing the soil at the surface. But you have to trace it back to the actual kimberlite pipe that's buried. And the truth is that there have been a number of kimberlite pipes discovered by this method of tracing the geochemical anomalies and the indicator minerals, tracing them back to their source, including some very rich ones both in Canada and in Africa as well. This is a version of tracing those the indicator minerals from the source all the way downstream, and shows how different minerals will travel a little further as the the concentration of minerals goes downhill or away from the source. You can see that the little red diamonds are the actual pipes themselves in this area. The darker green is a mineral called chromite, which is the main ore of chromium, and is also very heavy. And you see it only goes a little ways. A little farther spread out, the light green, the chrome diopside, it goes a little farther away from the pipes. And then even farther out is the orangey colored garnet line, and then way out, long ways, is this concentration of magnesium-rich ilmenite. And you can see by this map that the little line at the bottom, that's 75 kilometers. So you can see that the trace going out from these kimberlite pipes is huge and goes out for hundreds of miles at the far downstream end. And so, these things can be traced for a long ways. And this technique, like I say, has been used very successfully by geologists to find kimberlite pipes.
So we talked about the kimberlite indicator minerals. Let's talk about the practicalities of kimberlites and similar rocks. Let's talk about testing them and that sort of thing. And one of the things to know about kimberlites is that not all kimberlite rocks have diamonds in them. There's actually quite a few kimberlites that are either they're barren, completely barren of diamonds, or they have very little diamonds within them. Only a few, just a small amount. And ones that have some diamonds, but not enough to be economic, those ones, the sub-economic kimberlites, are, often give rise to placer deposits. Diamonds are very durable and very hard, and they last in a stream environment. They don't weather and disappear like some of the other minerals in kimberlites. The diamonds will last, and they'll get into gravels, and like gold, they'll stay there. And diamond's a little heavier than average rock. Gold, of course, is a lot heavier than average rock. But there are certainly placer deposits that are for diamonds, and they're mined all over the world in a lot of different places. When new deposits of kimberlite are found, and it's definitely kimberlite, there's a series of tests that they do. They can take a small amount, a relatively 5 or 10 pounds, comparatively small amount, and do a digestion, and basically eat away with acids all the rock and leave behind whatever micro diamonds that might be in that sample. And so they'll analyze the sample for microscopic, really small little diamond crystals, and that will give them an indication of whether or not this is a kimberlite that has significant diamonds in them. And of course, if you have significant diamonds from your initial test, then they keep doing more tests, larger and larger bulk tests, until eventually they may do a run of 50 or 100 tons of material and sort it out and see what diamonds they get out of it, because that'll give them a better indication of what percentage of the diamonds are actually gem grade and what percentage are industrial diamonds. The drill holes that they do to test these things, when they find a kimberlite, they put down drill holes, and the drill holes may be anywhere from 150 up to 750 feet deep. Now, diamonds, like I say, if there are diamonds in the kimberlite, they're measured in either what's called carats per metric ton or carats per 100 metric tons. And believe it or not, even in valuable kimberlites that are economic and rich enough to be mined and worked, the amount of diamonds in the rock is comparatively small. Literally, an average grade for a good diamond-bearing kimberlite would be something in the order of about 1/4 of a carat per metric ton. So you'd have to mine 4 tons of rock, it's metric tons, so it's even more. It would be 8,800 pounds of rock would yield you, on average, about 1 carat of diamond. And a carat, of course, is only a fifth of a gram, 2/10 of a gram. So diamonds are real valuable, but even diamond-bearing rock that's fairly rich doesn't have a lot of diamond in it. And even when you do have that, when you have diamonds, and you say, like I said, you mine 8,800 pounds of rock to produce 1 carat of diamond, in most kimberlite pipes, about 2/3 of the diamonds that come out are actually just industrial grade and not suitable for any kind of gem use. Only about 1/3 of the diamonds that come out are suitable for gem type uses. But they're pretty big deposits. An average kimberlite pipe will have somewhere around 26 million metric tons of ore that could be mined, rock that could be mined and processed for the diamonds. But of course, each deposit has its own characteristics, and the numbers that I'm giving you here are just what's typical when they test the kimberlite ores, and each one has to be analyzed and tested for its own characteristics, whether it's maybe richer than average or less rich than average. And there have been a lot of kimberlite mining. Historically, there's been kimberlite mining in the United States, and more than just the Murfreesboro deposit. There actually was an operating kimberlite diamond mine in Colorado for some years. They didn't get enough diamonds out of the material in order to really make a profit. Let me show you some of those Colorado diamonds, and we'll talk a little bit about it.
Here's some of the diamonds from that Colorado kimberlite pipe. And I think this pipe was only discovered in the 1980s, and it was worked in the 1990s, and then eventually the company went out of business. But still, there's some diamonds to be found. And as geologists note, a lot of kimberlites are covered over. They're not real obvious. And so discoveries continue to be made. And so it's worth going out and looking for them yourself.
Now, in all types of prospecting, what you know makes all the difference in the world. And whether you're looking for diamonds or other gemstones or gold, silver, platinum, whatever you're looking for, what you know about the geology and about the deposits makes all the difference in the world. Whether it's a hard rock deposit or a placer, alluvial gravel type deposit, whatever, what you know makes all the difference in the world. Now, if you're interested at all in gold, well, I wrote a book. It's called Fistful of Gold. It has some stuff about diamonds and platinum in it, and covers a few other things, but it's principally about gold because it's called Fistful of Gold, because that's what I want you to be able to go out and find for yourself, is fistful of gold. And I'm going to tell you a little bit more about my book, because it's very highly appreciated, and a lot of people have bought it and like it a lot. So I'm going to tell you a little bit more about my book right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount, I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at NevadaOutbackGems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done. And so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.